So number one, it says, let f of x be that. Then it says, as x goes to infinity, what happens to f of x? In other words, what is the limit? Oh, as x goes to negative infinity of f of x. So for this, we can just look at the graph of the function. So if we graph it in our calculator, we put in 5.4 plus 3.1 times 1.6 to the x. And it looks like I'm just going to put it in my standard window, zoom 6, and it looks like this in my window. And so what it looks like is that I have some sort of a horizontal asymptote. And so what this is asking is, as x goes to negative infinity, in other words, as I move to the left, what is my y value approaching? So the question is, what is this y value approaching as I move to the left on my graph? And so I can go into my I can go into the table. And so I can look at that, and I can go put in negative values, and it looks like it's getting closer and closer to like at negative 20, it's 5.4003, and so it looks like it's getting closer and closer to 5.4. So this is equal to 5.4. Okay, and then does f have a horizontal asymptote? And it is yes. And so what is that horizontal? It's the y equals 5.4. So this line, this dotted line, is the equation of the line is y equals 5.4. So for the next one, we can again take a look at the graph of this function. So if I graph the function, if I just use my standard window, I don't see the function very well, but I did my x out to 100 and my y, I went up to 30. And if you do that window, you should get something that looks like this, and it kind of levels off there. And so it seems like it has an asymptote like that. And so I can just, I'm just gonna do trace and just plug in a big value. I just plug in 100. I got 22.999. And so it looks like as my n is getting bigger and bigger, it's approaching 20, it looks like it's approaching 23. And so what is the meaning of the 23? So it represents that the number of pieces a new employee can assemble on the end of the day. So as n gets bigger and bigger, as they get more and more experience, they get closer and closer to being able to assemble 23. So an experienced worker can assemble 23 pieces per day. A 5-year CD is open with $6,000 initial deposit at an annual rate of 2.9% compounded monthly. How much money will be in the CD at the end of 5 years? Okay, so what we have is 6,000. And then the annual, so we're going to do 1 plus the rate. Now the annual rate is 2.9%, which means the monthly rate is going to be 0.029 divided by 12. And I want to raise that to the number of months. So in 5 years, it's going to be 5 times 12. It's going to be 60 months. So I'm going to plug all of that in my calculator. I got $6,935.02. Okay, and then what is the effective rate for this CD? So the effective rate, I think what I'm going to do is I really want to do the 1 plus 0.029. over 12, and all that's raised to the 12th. 1 plus 0.029 over 12 to the 12th, and that gives me 1.02938. And so then this is my rate here, is this. So that's 2.94%. Okay, so that's my effective yearly rate. Okay, so in other words, it is an annual rate of 2.9%, but because it's compounded monthly, it's the same as just doing, if I do 2.9% compounded monthly, that would be the same as 2.94% compounded yearly. That's what we mean by effective rate. Okay, suppose 2 milligrams of a drug is injected into a bloodstream as the drug is metabolized, okay, diminishes at a rate of 4% per hour. Find the formula for the quantity. Okay, so our initial amount is the 2 milligrams, and then my rate is diminishing at 4%. So Q of T is going to equal 2 times E to the negative 0.04 T. For the next one, I want to find it in that form. So basically what I need to do is figure out what this number is. So if I do E to the negative 0.04, that gives me 0.96078. Hang on, how many decimals do I need? 9608 is good. And then so the Q of T is equal to 2 times 0.9608 to the T. By what percent does the drug level decrease during any given hour? So if I did 1 minus 0.9608, I get 0.0392, so 3.92% per minute per hour. Okay, by what percent does the drug level decrease in 5 hours? So I can look at 0.9608 raised to the 5th. And that gives me 0.81878. And so I can do 1 minus 0.81878, and that gives me 0.18122, so 18.122% in 5 hours. Okay, so then an investment increases an amount at a continuous annual rate of 4% for 8 years. By what percentage does the investment increase over the entire 8-year period? Okay, so let's see here. So I want to say it increases at a continuous annual rate of 4% for 8 years. So we can say, so we're going to say E to the 0.04 times 8. And so if this was the original amount, I'm just going to call it A, then I can do E to the 0.04 times 8. So that gives me A times 1.377. So it grows by 37.7%. All right, so this is about logarithms. Solve the equation exactly for x. Okay, so I can use the fact that e and natural log are inverses of one another, And I can say 10 to the x plus 1 is equal to e squared. And then I get 10 to the x is equal to e squared minus 1. And now I can take the logarithm of both sides. Log of 10 to the x is equal to log of e squared minus 1. So x is equal to log of e squared minus 1. So that is the exact value. And then it says rounded 2 decimals, but I think we're supposed to show an exact value. So that's kind of confusing to me. Does it want both? Round to 2 decimals if rounding is needed. Okay, I guess I'll just do both. So in my calculator, I can type in log of e squared minus 1, and my calculator is giving me 0.81 as my rounded answer. Okay, so for the next one, I can, well, first of all, I'll notice that there is a constant multiplied out front of both of these, so I can divide one of those constants over. It doesn't matter which one. I'll just divide the 8 on both sides. So this is 7/8 e to the 6x. And now I can take the natural log of both sides. So I get that the natural log of e to the 5x is equal to the natural log of 7/8. 7/8 e to the 6x. And then, so this is just reduces down to 5x, and this is natural log of 7/8. Since this is a product, it breaks up as a sum, plus the natural log of e to the 6x, which is just ends up being 6x. And so now I want to get the x's onto one side, and so I can subtract the 5x and subtract the natural log 7/8, and I get x is equal to negative natural log of 7/8. Which is equal to the natural log of 8/7, because this negative can come up as a power, and that's equal to the natural log of 8/7. So whichever way you got, negative natural log of 7/8, same thing as natural log of 8/7. And you can plug both this in your calculator and see that they give you the same value. The rounded for that, if I do natural log of 8/7, that gives me 0.1335. Okay, now I have this. Okay, so I can combine those. So this is the log of x times x minus 3 equals 1. So I can just use the definition of log. So this is 10 to the 1 equals that. So 10 equals x times x minus 3. This ends up being a quadratic. So I get 0 equals x squared minus 3x minus 10. And so 0 equals, so I can factor that. And so I'll have negative 5 plus x, x minus 5, and x plus 2. And so I get x equals 5 and x equals minus 2. We do want to go back and make sure when we get this kind of thing that the solutions that we get both are able to be plugged into the original equation. And I know that for logarithms, you have to plug in positive numbers. So if you plug in negative 2 into log of x, that gives you something that's undefined. So we end up throwing out that solution, and the only solution is x equals 5. The last one, it has 10 to that and e to that. So you can do it, you can choose whether you want to take the log base 10 of both sides or the natural log of both sides. It really doesn't matter. I guess I'll just take the log base 10 of both sides because the 10's on the left. I don't know. It doesn't matter. So if I do log of 10 to the 2x plus 5, that's equal to log of e to the 7x plus 3. And so this undoes each other, so I get 2x plus 5. And then on this side, I get equals 7x plus 3 log of e. And then I can multiply this into both of those. And so I get 2x, and I'm going to subtract the 5 over, and I'm going to subtract 7x log e equals 3 log e minus 5. And then I can factor out an x, or sorry, 2 minus 7. Log e. So I get x equals 3 log e minus 5 over 2 minus 7 log e. Okay, and so, yeah, and then if you get a decimal approximation for that, if you type that all into your calculator, you should get 3.55. Okay, next. If the price of a gallon of milk climbs at a continuous rate of 3% annually, how many years will it take for the price to increase by 50%? So our model is P equals A, B to the T. So that's A times 1 plus 0.03 to the T. And so the question is, how many years will it take for this price to increase by 50%? So in other words, I want this part to be equal to 0.5. So I can do 1.03 to the T equals 0.5. 1.5, because I need it to be 50% increase, so 1.5, yeah. And so then I just want to solve that for T. So I can take the natural log of both sides. So I get T times the natural log of 1.03 is equal to the natural log of 1.5. And then I can divide it over. So T equals the natural log of 1.5 divided by the natural log of 1.03. And if you plug that into your calculator, you get 13.7. So that means it'll take 13 point, How many years will it take for the price to increase by 50%? So I want 1.03 to the T to equal 1.5. How many years will it take for his price to increase? Yeah, I got 13.7. Well, I'm not sure why that's off a little bit. Okay, I'm going to move on. Suppose it takes a radioactive substance 36 years to decrease by 25%. Find the continuous decay rate. Okay, so we have that in 36 years it decreased by 25%. So I can say A times 0.75 is equal to A times E to the K times 36. So it decreases by 75% for that. So I can divide both sides by A. So I have 0.75 equals E to the 36K. Then I can take the natural log of both sides and divide by 36. And so for a decimal approximation of that, so natural log of 0.75 divided by 36, that gives me negative 0.00799. Yes. And then how long will it take the radioactive substance to decrease to 25% of its original mass? So A times 0.25, that's 25% of the original mass, is going to be equal to A times E to the negative 0.00799 times T. And I want to solve that for T. And so I can divide both sides by A, and I get 0.25 equals e to the negative 0.00799t. Take the natural log of both sides and divide by negative 0.00799. Oh, whoops. Negative 0.00799. So if I do a decimal approximation for that, natural log of 0.25 divided by negative 0.00799. That gives me 173.5 years.